Hey guys, so this is part 2 of the video for Journal 3. So in this part here, we're going to be talking about the definitions for increasing and decreasing intervals and something called relative mins and max. Now, when we're talking about increasing, that's typically when a function, let's pretend for a moment you have a coordinate system and you have a function that is going from left to right and it is going upwards like this. This is what we call increasing. So from left to right, the slope is rising. And so we call this increasing. And decreasing, so when the function is decreasing, oops, I forgot my A in there. That is when you have a function that's the opposite. When you're going from left to right, it is going downwards. So this is what we call decreasing. And so this is really important when we're looking at functions is to identify what part is decreasing and increasing and sometimes even constant. So when we're talking about a function that's constant, that's when you notice that the curve of the graph is just laying flat. So that's what we call constant. So it's not really changing, it's just staying leveled or flat. And so typically when we're writing a increasing or decreasing interval, we represent parentheses, kind of like what we've been doing in the past when we write domain and range, we write them in interval notation. So other things that I want to mention about is to tell about a relative minimum and maximum. So relative just means that within that curve, it is the highest point or the lowest point. So typically when you're looking for a relative maximum, that's when you're looking at a graph. Let me see if I can bring this up just a little bit. There we go. When you're looking on a graph and you notice that there are these hills, like here, those are what we call relative maximums. Let me write that in. So these are relative maximums. And so they are identified by their hill-like characteristic because they are the highest point in that little neighborhood. Whereas minimums, they're kind of known as like the valley of the graph. So like those dips in the curve, those are what we call relative minimums. And so they're known for that because they're the lowest point in those neighborhoods. And so in this case here, we're going to demonstrate these vocabularies using example 1. So use the graph to determine the intervals on which the graph is increasing and decreasing or constant and find all the relative mins and max. So let's start with increasing first. So I'm going to do increasing in green. So when I'm looking at increasing on the graph from left to right, I notice that this is going downward. So that's not increasing, that is decreasing. So I'm going to label that, I'll do pink. So this is decreasing, so I'm going to use a minus sign to represent decreasing. But after this point here, notice that it starts to curve on up. So this is rising, so this is increasing. And so it is rising between, and we have to look at the x values when we're writing intervals. So when I look at this point here, the x value here is right here, which is at -8. So it's starting from -8 and we're using parentheses like the direction said. So we always use parentheses for these types of intervals. So from -8 and it keeps climbing to here, which is at -2, it stops increasing. And so we're going to close that with the parentheses. After that, notice how it starts to fall. So in this case, this is a decreasing. But then it starts increasing again. And so, oops, sorry, I meant to use a plus sign. And it increases from 0, x equals 0, to x equals 2. So let's add that, x equals 0 to x equals 2. And then after that, it decreases. So I'm just going to put a negative sign. And then down here, it goes from 5 to 10. So when x equals 5 to 10, it is again increasing. So I'm going to write that 5 to 10. So I've done the increasing and I kind of labeled before the decreasing. So the decreasing starts from, this would be x equals 10 to about x equals -8. So I'm going to write from negative 10 to negative 8, it's decreasing. And then on our next scenario, it starts here. So that's negative 2 to 0. So negative 2 to 0, it's decreasing. And then we have another one here. So from 2 to 5, it's again decreasing. But when I looked at this line here, I noticed that there were no flat lines. Remember that constant line? It's kind of like level to flat line. I don't notice it here. It keeps going down, up, down, up, down, up. So it's never a constant level. So there's no constant interval here. So I'm just going to write none. Minimums, we actually have quite a few minimums here. So let me grab my pen. We have a minimum right here. So minimums, you want to look for those valleys or those dips. So we have a minimum there, a relative minimum. We have another minimum here, and we have another minimum here. So we have like 3 minimums. So I'm going to write the coordinates. When you're writing minimums, you want to write the coordinates. So we have a minimum at negative 8, negative 4. We have one at 0, 0, and we have one at 5, 0. And there we go. We have all our minimums. And then for our maximums, we got to look for those hills. And so those hills, we have one here, here. It looks like we only have 2 hills. You do not want to count this one here. The reason why is that's not really a hill. That is a high point afterwards, but it doesn't come down. So I don't know if that was a maximum or not. So you don't want to count this end one, just these 2. So I'm going to write those coordinates down at negative 2 and 6. And actually, that's not a 6. That is a 5, I think. Let me erase that. My bad. And then that one's a 2 and a 10. And there we have it. We have our maximums and minimums. All right, so let's check out example 2 here. So example 2, you are going to need a graphing calculator. So I recommend that you check out Desmos. Desmos has great graphing calculators to use. And you can just use your MacBooks to do this. So what I'm going to do is flip the camera so that way you guys can see what I see. Let me shrink this down just a little bit. All right, so I'm going to show you what I'm going to be doing on part A first. So part A has this equation here, and I need to graph it. Because if I don't graph it, I'm not going to be able to find the relative max and mins, and I have to find the most accurate coordinates for that. So in this case, I'm going to graph this first in Desmos, and I've already typed in the website. There's the website right there, just desmos.com/calculator, or you can just Google it and this should pop up. So here in the left corner, you are going to type in your function exactly the way it looks like on part A. So that's going to be doing the F parentheses, so X close parentheses equal sign, and then it's a 3x. Now notice that's an x squared that I need. So in order to do an x squared, you're going to need this button right here. So you're going to have to hit shift to get it. So basically you're going to hit shift 6, and notice when you do that, it goes upwards, and you're going to put the 2 in. And to get it back down, all you have to do is hit this like downward keys, and then it comes back down, and then you just keep adding. So it has a minus sign, so I'm going to type in a minus sign, 4x minus 2, and it just drew me the picture here. So I'm going to do my best to draw this as well on my coordinate system, but I'm going to zoom in just a little bit so that way we can see a little bit easy. So there's it looks like it has one minimum. So I'm going to pause it right there for us. There we go. And so looking at this here, I'm going to try to do my best to draw it. It looks like it's a little bit over 3 for the minimum for the y value. So it's like somewhere down here, and it looks like the x value is not even at 1 yet. So it's like right about here. And then it like scoops up somewhere about here. So it's pretty skinny. Like something like that. But all I know right now is that this here is a minimum, right? And I don't see a maximum here. There's no hill here. So I can already say for the maximum, there is none. For the minimum, on the other hand, what you're going to have to do is use your cursor and get on the Desmos really close. So I'm going to try to do that here. Let's see, if I scoot this over, just do another video. All right, so in this video here, what I'm going to do is use my cursor and try to get to the minimum right there. So I'm going to pause it right there, and now I actually have the exact value. Okay, and so I'm going to grab that value there, and I'm just going to do 3 decimal points here. So I might need some room. So for my x value, looks like it's at 0.667. And then for my y value, it looks like it's at negative 3.333. And so that looks like my minimum value that I have. And so that's how you do it on Desmos. If you have a TI-84 graphing calculator, you can also do this as well. There's a bunch of YouTube videos to show you. But in this case, using Desmos is perfectly fine. Let me show you how to do the next one here. So again, let me grab my camera so that way you can see this being typed in. There we go. So what we're going to do is just type in part B's graph, which is x negative x. Put a negative in here. And I need a cube, so remember Shift 6 to get that exponent. And then you just want to come down with your arrow key. Plus, so I need to hit like Shift plus sign with a x. And so there we have our graph. And so in this case, I'm just going to pause it right there. And so our graph does have a max and a min. So I'm going to do my best to try to draw this first. It looks like the min is between -1 and 0. So I'm going to kind of draw it where it's really tiny. It's like here. And then the other one's like opposite of it. It's like between 0 and 1, but it's in the positive region. So it kind of goes like this a little bit. So for the min, what I'm going to do is do the same thing. I'm going to do a close-up of it. This time I'm not going to show it to you. I'm just going to look at it on my computer. So hopefully when you type it out, you get the same numbers as me. But I get it to be -0.577 and -0.385 if I just use 3 decimal places. Now for my max, I do have a max right there. So this relative max is actually very similar to the other one, but it is a positive 0.577 and 0.385. All right, that's it for this part of the video. In the next video, I'm going to show you how to look at step functions, something called step functions.